Okay, so let's do a little bit more work with radians, specifically finding the least positive coterminal angle and reference angle. All right, so we need to determine the quadrant in which the terminal side of our angle lies. Well, with degrees, we looked at, is there more than one full rotation? Well, how do you determine that with radians? Well, let's think about it. One full rotation is 2 pi radians, which is how many pi over 6 sections is that? Well, 2 is equivalent to 12 pi over 6, right? So I double that denominator again. So I know 17 is greater than 12, so I know it's more than one full rotation. So as we did before with degrees, we are going to subtract off the full rotation. But now we're doing it in radians. So I'm going to subtract one full rotation of 2 pi. So use my common denominator, 12 pi over 6, and I'm left with 5 pi over 6. Okay, so I know 5 is less than 6, so I know that's actually less than pi, because remember, pi would be 6 pi over 6. So if I'm talking about an angle in the standard position, that is less than half of a rotation. Okay, so that's what I would call my least positive coterminal angle, which we like. That helps us determine the quadrant. So here I have my 12 sector circle, and we know that each sector is 30 degrees, or pi over 6. All right, so if my initial side here and the terminal side, then I would go 5 pi over 6 radians. So that is basically 5 of those sectors. So we can count off 1, 2, 3, 4, 5. Or what's really nice to recognize is the fact that this is 5 pi over 6, the terminal side here going through here. Well, notice how the relationship to pi, which is 6 pi over 6, so it's one sector less than that. Okay, and that's what we find helpful there for graphing. All right, or excuse me, actually determining the reference angle, excuse me. Okay, so then I say, all right, I want the reference angle. Oh, whoops, I forgot quadrant, my bad. So it terminates in quadrant 2. And the reference angle then is this distance from the terminal side to the x-axis. So this is my reference angle. So if I have my sector circle, it's pretty easy to tell the reference angle because I know it's one sector short of going pi radians, so I can see that it's pi over 6. If I did not have my circle, then I could say, well, it's short. We didn't quite get to pi, so we take pi and we subtract off that 5 pi over 6. And what is that difference? Well, pi is the 6 pi over 6. Subtract 5 pi over 6, which gives us pi over 6. Okay, so it's just like we did with reference angles in degrees, except now instead of using 180, we use pi. All right, let's look at another one. So negative 7 pi over 3. So I'm doing a negative rotation. Now let's think about that. One full rotation, 2 pi, is how many pi over 3 sections? Well, it would be 6 because 2 is equivalent to 6 over 3. So if I'm going 7 pi over 3, I'm going more than one full rotation because 7 is bigger than 6. Okay, so I'm going to start with my initial side here, and I'm going to go one full rotation and then some. Okay, well, what's that then some, so to speak? Well, we know we can always get a positive coterminal angle by adding 2 pi. So this is one way of looking at it. I can find the least positive coterminal angle by adding 2 pi. Well, I still have negative pi over 3. Okay, so if you're thinking in the negative direction, you're going pi over 3 beyond 2 pi in the negative direction. But if you want to get to the least positive coterminal, then you just continue to add 2 pi until you get a positive angle. So I know 2 pi is 6 pi over 3, so I'm going to continue to use that equivalent fraction. So negative 1 pi over 3 plus 6 pi over 3 is 5 pi over 3. So that is my least positive coterminal angle, if you want to work in terms of positive measures. So if I want to go 5 pi over 3 in the positive direction, then remember 2 of our sectors is pi over 3. So I'm going to go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So 5 pi over 3 has a terminal side here, and so does negative 7 pi over 3. So this angle terminates in quadrant 4. Now, what's my reference angle? The reference angle would be this distance here. Okay, well, we can see then that that is one of our sectors. That's pi over 3, so my reference angle is also pi over 3. Now, some people would like to say that it is negative pi over 3, but reference angles are always positive. So even though we're going from the terminal side to the x-axis, it doesn't matter the direction, okay? And there we go.